All right. And let's give our feed a moment. I feel like I need to have like a graphic that has like things happening and
Like a
things
loading
connecting
graphic.
and whatever it is out there.
The
But all
the
right,
old
now it says we're connected.
the old Windows scroll bar, right?
Oh no, people would no that would give me that's PTSD, man. All right, here we go. Good morning, good afternoon, and good evening, live viewers, and those of you listening later. Welcome down the security rabbit hole to another edition of the Down the Security Rabbit Hole podcast. This is Raph. That's James. In the middle is this guy named Gerry. We'll get to him in a second. But James, hey man, welcome back.
Hey, it's nice to see. We recorded the other day. It was dreary. Today it looks actually nice outside. So I got a positive spin on how this whole day is going to go.
All right. Well, it's still dreary here, but today, yeah, I've been doing like a sports jersey every day this week for some reason, and I went back and I pulled out the Flying Fijians, World Cup from Japan in rugby when we were down in Fiji. I bought this jersey. I haven't worn it in a while, so it's kind of cool. I'm wearing. Go back to sports representation. All right, let's get to our guest because the topic today is the urge to converge, and it really is a convergence discussion on networking and security, but there's probably be more to it. With that in mind, Mr. Gerry Plaza, Gerry, welcome back from vacation and welcome to the show.
Yeah, no, I appreciate it. This is a great segue back into work as you come off vacation. So happy to be here with everybody. Thank you.
So, where do we start? I think we should start with the fact that convergence was something that I maybe it's inevitable, I want to say. But when we started in security, James, security wasn't separate. It was just part of the network function and the systems function. We separated it out necessarily by practice and for practical reasons and others. And then operationally, it got split. And Gerry, I feel like over the last couple of years, there's this rare earth magnet sort of pulling us back to center as technology, as techniques, as concepts, just pull network and security ops teams and engineering teams back together. What do you think?
This push and pull of convergence has been going on for decades. The concept of convergence always comes about because there's got to be a better way to drive efficiency, operational costs down, agility into the business. And so teams look at, hey, what are we doing with our infrastructure? And if we go back before even virtualization, you can go back to mainframes, and mainframes started this convergence. And then virtualization came about and it started pushing this thing back out. And then we started converging again and taking these servers and virtualizing everything, that concept. So we've been doing this continuous iteration of convergence and distributing back out for decades. Now, in my opinion, and what I'm seeing in the industry is finally a collection of technologies that are converging multiple teams. And that's the difference of the convergence we're seeing today versus the convergence we've seen in the past. In the past, it was just converging hardware, converging components, converging systems. Now we're converging all of that plus the technology, the priorities, the goals, and the future direction of operational teams inside of companies. And there's been one big catalyst that's kind of really forced and accelerated all this, and that's what happened in 2020. I think we're all very familiar with that. And what that did was it created this requirement in that you could no longer do nothing, right? Companies that needed to stay competitive were doing digital transformation. And that in itself was creating some convergence. But there were other companies that were kind of just delaying the change, going across the idea of this is the way we've always done it. And they were forced out of that comfort zone just to survive. And that's the difference that's happening today and versus how we've been doing this convergence thing for the past several decades.
What makes, because I feel like it's kind of an instrument I used to play, the accordion, right? You go, nah, 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 nah. So what's different this time? And I didn't want to kill your cadence because you were killing it there. Well, good explanation. But what's different about this version of the convergence of networking and security concepts. Like why is it better? Why is it going to stick this time? Why does it make sense now?
Yeah, I think fundamentally what's different is in the past, convergence is all about creating efficiencies in the infrastructure, right? Servers were deployed and they were only 10% utilized across the industry. And they're like, well, why don't we just virtualize them and make them 90% utilized? And cool, it drove efficiencies and it reduced costs. So it was all about reducing costs, driving efficiency really in the past. What is different this time is about the idea of speed and agility to stay competitive, to stay relevant in the marketplace. You've got to be able to be continuously integrating, continuously developing your capabilities, your technology, your services for customers, because we as consumers are no longer loyal to any brand, right? You imagine you pull out your phone and you go to use an app and that app pauses, freezes, you have a bad experience. What's the first thing you do? I'm gonna go find another app.
Yep. Done.
Exactly.
Fair.
We jump ship. Therefore, companies no longer have the ability to stay stagnant. They have got to continue to innovate to capture the audience, capture the consumer. And that's what's different, is convergence is being driven by the necessity of being agile and accelerating their path towards digital transformation and future enablement. And that's why it's going to stick, because if you don't do that, you become irrelevant, and then you fall to the wayside like Blockbuster, right?
Is it also
as one
tied in? Is it also tied into though the idea, because talking about like CPU usage and, you know, hey, let's go to virtualization. That's single team, and you had mentioned before this is kind of cross team. We're talking security now, so you know, having that ability, like we saw in 2020, right? That need, like no longer could you just say, hey, I'm just going to go remote, but hey, we have to secure that, but I don't have resources to secure that. So now we have to kind of bring those things together and say, hey, I don't have resources for two teams. I have resources for one team. Does that kind of force some of that convergent too? Like, hey, I can't go out and find this, or there's a lack, right, of resources to be able to do it. Like there's, you know, a shortage, all that stuff. Like, does that force some of that convergence? You know, we're more on the operations side than we are even the tech side almost.
No, it most definitely does force the convergence. It also comes to the fact that when teams work independently, they're overlapping. One team has to then wait for the other team to do something before they can do something, and it slows the business down. And so therein lies a lot of the force of the teams collaborating, because I can no longer get to point, you know, Z without bouncing through all these other teams. Therefore, if I work together, we can efficiently get to point Z from point A, right? As opposed to waiting for, you know, the D team to get their act together before I can continue moving forward. And so it's a means of moving faster.
I'm curious to know, like, how far does it end up going? Because I mean, I've mentioned before, Raph, on the podcast, right? Like, why do we have a knock and why do we have a sock? Why don't we just have one?
See,
Did we get to that point?
You know, I think technologies and let's just talk artificial intelligence is absolutely going to help us get to close to that point. Now, the reason we've always had separate teams operationally, you know, from an engineering perspective and from a technology perspective, was the skill sets. It took certain skill sets to be a network operations command center individual versus a security operations command center individual. You looked at the world differently. And this idea that I have a different way of looking at the business objective and the goals versus the other teams is slowly mending together. Because, hey, I need to, if I understand networking, I could be better at my job in security. And if I understand security, I could be better at networking. And so this idea that they were completely isolated teams is starting to mend together. Now, artificial intelligence is really bringing those concepts together, because now I can take advantage of tool sets that help build insights that individuals can then and humans can then interact with on a more rapid basis. And so without a doubt, I think AI is that next catalyst that's going to push this convergence of independent skill sets kind of going away. And we're going to become more, think about it, right? Like prompt engineers, right? It's just a matter of me typing in a prompt of, hey, when was the last security incident that saw this type of alert in the network? And AI goes out and finds it.
I don't know if I buy that, Jerry. I don't know if we're getting there, man. I all the AI hype to me is, I think, overblown. I don't mean to throw cold water
No,
on
sure.
your fire here, but
Yeah,
I think it's
absolutely.
overblown. I think the AI we have today is, I think naming it generative is a little misleading because it's regenerate, like it's regurgitative.
Yeah.
It can take other things and put them back together. So will it be able to find things that we don't know about? I don't know. Maybe. Will we all end up as prompt engineers? I doubt it. I really do. I think. I just think the human brain is so vastly superior to any computer technology we can. Now, not in looking at large data sets, right,
Yeah,
and analyzing petabytes of information for patterns and identifying issues. That I'll give the computers all day long.
Yeah.
But looking at something and saying, that's weird. You know what that could be? And making those decisions and deciding what to investigate, what not to investigate, how much to investigate it. I think that stays in the squishy stuff in our heads.
No, you hit it on the head, Raf. It's the large data sets. And when it comes to security and alerts, there's a real concept out there called alert fatigue, right? You have so many indicators just slamming into the SOC that how do I discern what's real, what's not? How do I create patterns out of it? That's where AI gets really, really good at. And so it's going to help improve our ability in our efficacy around security posture based off the fact that I can now start to create correlations. But to your point, human interaction is going to need to be involved for the foreseeable future. There's just no displacing a human decision versus what a computer might just guesstimate. Because to your point, generative AI is not really doing anything intelligent other than predicting what's the next word in a sequence.
That's right.
Yeah.
So, okay. So let's go back to, I like James's point, and I think it's interesting about bringing the knock and sock back together. And here's why I think this is interesting, right? So, we're both coming from a security approach right now, Jerry, in our day jobs, where the network is the source of truth, effectively, right? And I can lie to the endpoint. I can manipulate logs. I can subvert an agent. I can do all kinds of things. But it's really hard to lie to the network, because if you have to pass a packet between host A and host B, you have to traverse that network, which means somebody, if they're watching, will see you. Now, how well can you hide the intent and content and all that of that thing you're trying to do? There's been some pretty damn good attackers out there. I'll give them that. Like, there's been some creative stuff. But this is where I think where convergence really gets its power, and the way I'm thinking about it, I think it's pretty similar to your thought process, where the network is where we will enforce policy. And it's not like the corporate network where we can simply say the firewall disallows you from going here to here, right? Because out on the internet, well, we're talking about effectively everybody is out on an open network at sufficiently far enough in the future. I don't even know if this is like 10, 15 years, but I think a lot of corporate networks today are basically giant hotspots. They may as well be Starbucks, right? Like you go, no, seriously, I've been to a bunch of corporate offices where you get on their network and they're like, yeah, all we do is provide internet. Like all the security happens elsewhere.
It's called zero
and
trust.
That makes sense, because the old models of people remote working, VPNing back to the central office aggregating all that and pushing it back out, that doesn't make sense with today's connectivity, which means the security of our network has to happen out there.
Yeah.
And whether you're talking about SD-WAN, whether you're talking about ZTE, ZTNA, SS, I don't know, all those SASE, zero trusty acronyms. I think that's where the security has to happen. I can subvert the endpoint, and I maybe even don't even have to trust the endpoint, because maybe I'm just allowing people to use whatever tools they have at their disposal. And back a million years ago at a job I had, we had laptops that were out in the field for months at a time in between check-ins to the corporate VPN.
Mm-hmm.
They still accessed sensitive data. They still did work. They did all the other stuff they needed to do. And so like at that time, obviously we were like, oh my God, we don't know what's happening to those. Today we actually can, because you don't need the physical wire anymore. Am I ranting a little too far off base? Or am I right?
You are literally talking exactly why SASE, right? And we start talking about SSE and SASE and everything else is becoming so prevalent in corporations. Now, the idea that corporate offices are becoming Wi-Fi hotspots is right smack already in the concepts and implementation processes for a lot of companies. Companies are looking at that idea as, why do I have a corporate network if my users are not even on the corporate network anymore, right? They're working from home, remote, or whatever, wherever they might be. And two, I can't necessarily even trust those endpoint devices that are on my corporate network. Therefore, why am I treating it like something that's inherently trusted?
Right.
So companies absolutely are looking at the concepts of moving to hotel type situations where you just have a desk, you can come and sit down, and it's just open corporate or open public Wi-Fi, because that's all we need. Now, if you look at traffic patterns of corporate users, 70%, that's the traditional industry direction of traffic that is just going straight out to the internet anyway. So if 70%, 3/4 of my traffic's going out to the internet anyway, why do I need a corporate network with all of this stack of infrastructure and security controls and concepts that are just not effective for the type of traffic patterns we have today? So without a doubt, right, we use this concept that the internet has changed. The internet is now truly your corporate backbone. It's your corporate network, because most of your applications are SaaS. Your users are distributed everywhere, accessing applications and data everywhere. So how do we effectively secure those users while at the same time providing the best user experience? Because therein lies the challenge. How do I secure you without trading off performance and user experience? Historically, that's always been a trade-off. If I give you performance, I got to scale back my security. If I lock you down, my performance and my user experience sucks. How do we do it effectively at the same time without compromise? And that's by pushing the security to the edge. And by the edge, meaning closest to where the users are. So if I'm in St. Louis, which is where I'm located, I should be connected to a security cloud that provides all of my inspection points, my visibility, my controls, and my policies closest to where I'm at. So maybe I connect to Chicago for a point of presence. But then when I move and I fly out to LA, I connect to LA, or if I'm in Italy, where I was just at, I should be connected to Italy. I shouldn't have to backhaul all the way back to St. Louis just to go back out. And so that's the concept that's coming about, is creating security clouds that are closest to the users so that we can give you the high level of performance you need while providing the policy and the security that is necessary to protect data.
I think the key point there that on the timeline of history was the dramatic shift towards software as a service and everything as a service, right? Once we started doing that, the number of the applications that had to be installed in your corporate perimeter dramatically went down. And so a lot of the things that we would use the corporate network for simply went away. And now the things that we access, whether it's HR, whether it's our CRM, engineering tools, whatever, it's out there beyond our corporate perimeter. So the loss of control necessitated a new model.
Without a doubt, right? The loss of control and the loss of visibility. Visibility has been one of those big challenges that is driving a need for a new way to do things. As my traffic was inside my perimeter, I had all kinds of tools, instrumentation. I can follow packets. I can do everything I needed to provide the security and controls necessary. But then as soon as it left my perimeter and I egressed outbound, I lost visibility, I lost control. And if I don't have visibility or control, I don't have security posture that I can apply to that traffic. And so therein lied the necessity for something to happen. Something fundamentally needed to change. And it's where we applied that security control and policy had to leave the perimeter because our traffic was no longer inside that perimeter.
All right, so let's talk about then, because we've been conceptually talking about it. Let's make it concrete. Talk to me about the new model specifically as it relates to why we think that the network ops and security ops teams are starting to converge in that new model.
You hit it kind of on the head a little earlier. You're dancing around it. So to solidify the concept, right, is you can't get anywhere without the network. If I'm trying to get those applications, whether they're on-prem, off-prem, in the cloud, or anywhere in between, I've got to traverse a network. Well, then once I'm traversing the network, how do I apply proper security as things have gotten increasingly complex because our users are distributed everywhere, our applications, our data distributed everywhere? Well, we've got to work together, we as a network and security teams. And so it's this idea that I, as a network individual, route packets, security teams inspect and apply policy to those packets. So if we can work together, then I can apply the right security controls to the right areas on the network to allow and deliver the right security for the right times, for the right reasons, to protect the right data. And therein lies that need for that convergence. Is we can no longer have network teams creating routes and connectivity without the security teams understanding where that route and where that connectivity lies, so that the right security controls can be applied, because we're no longer backhauling all that traffic to one location. And that's great because I had my security stack at that one location. That concept has pretty much gone away, and it's no longer effective, which is what's driving this industry concept of security clouds and pushing the policy and the controls closest to where the users are, which is everywhere but in office these days.
In that implementation, are we going back to an agent-based or agentless world? Like, what does that look like? And how does that mesh get built? How does that, I guess I can call it an overlay network, right? Because we're riding the public network in a point-to-point secure manner, on demand. So those tunnels aren't pre-existing. They get built on demand. We have policy-based access. We have conditional access. And that is based on security policy, that is based on authentication. Like, there's a lot to it.
Mm-hmm.
Where does that get orchestrated?
So I do business today, it needs to be both. And I hate to say it that way, but both being agent and agentless. Agent, because agents just allow us to have a deeper level of inspection and control over what's happening to traffic into the data. And we've got a tremendous amount of critical business data that's out there. And so it starts to become gated in the sense of, hey, I'll give you access to this corporate data, but you've got to meet certain criteria. And maybe one of those criteria is an agent. But then at the same time, we use 5 different devices. We have iPads, phones, right, different laptops. I might use a kiosk and connect to something if I need to. So therefore, I have to allow and enable access agentless, because I can't apply agents to certain devices, IoTs out there that can't run agents. I'm not going to let you put an agent on my personal cell phone yet. Right. I use my personal cell phone for corporate business. Therefore, you need to also enable agentless. But therein lies the differences, right? Agent's going to give you one level of experience and control, where agentless gives you another. And so when you have this new concept of adaptable security, now that starts to become effective. And that's what we're driving within the industry at Netscope, is this concept of, you don't just say, I have zero trust and stop. Because once I give you access, I'm now trusting you with access to that data. However, what if you change your behavior? Or what if you switch devices? It is still my identity. It's still my user ID, my password. I still should have access to it. but I'm coming from an unsecured or unknown device because I don't have an agent. I can't understand. I don't know what the security posture is of that device. So maybe I'm going to adapt your policy. Maybe I adapt your security control. Instead of giving you full blown read, write, download, I'm only going to let you read, or I'm only going to let you upload. And so those are the new concepts and capabilities that are coming out into the industry via SASE. And what Netscope's kind of driving into the industry is this idea that don't just stop at zero trust, but go beyond zero trust and go to adaptable trust. And that's what provides the best user experience while providing the capabilities to control and provide security policy to the right data at the right time.
All right. That makes a lot of sense. I'm trying to figure out how to formulate kind of where I want to go next with this, because that gives us a really interesting view of how to build the next generation of network and security operations. Because you said it's got to be done at both, right?
Yeah.
How do you keep that from being a mess, to put it politely?
Both in agent and agentless, or network and security?
Well, so in both worlds, right? So some things you can, because you're right. I'm not gonna let you put an agent on my personal laptop. I probably not on a kiosk that I'm just getting onto. That's probably somebody else's. So how do you keep it from being a mess? Because some devices can enforce policy to a higher degree than others. Some are newer. So that kiosk has probably had the latest patch level of applied sometime around the Clinton presidency. Meanwhile, I wish I was kidding. Meanwhile, my iPad, right, hopefully is up to date. And my personal phone, don't know. My work one better be up to date. How do you keep that consistent from a network person? How do you keep that consistent? So how do you keep keep giving people access while still maintaining a reasonable level of security that you dictate? Because I'm struggling with that a little bit.
No, I totally understand where you're going with this. It's the idea that you cannot use just one vector of inspection to make a decision on what type of access I should give you. So I'll give you an explanation on that. What we've typically done in the past is we used your user ID. RAF, you enter in your user ID password. I bounce it against an identity management tool. Does RAF have access to this app? Yes, I'm going to give you access. Yeah, but what if RAF was coming from a kiosk? What if he's coming from his personal cell phone? What if he's coming from an untrusted device? Should I have given RAF access? No. Therefore, I shouldn't only use identity. I should then use device. Okay, what if RAF gets his device stolen and somebody compromises your ID, and now all of a sudden somebody's trying to log into that application using RAF's ID, using RAF's device, but they happen to be in England, right? Location. Well, then that means I need to use location as a possible trust inspection point. All right. Well, they using a personal device. RAF's connecting from a trusted location. Let's say logging in from the US. So we see that as a source IP. But you're accessing from a personal device, but you're trying to get to an application that has critical business data. Should I give you access to it unfettered, right? With full upload, download, copy? No, because you're on an untrusted device. Maybe I'll give you visibility, but I'm not going to let you download copy. So that means I also have to take application as an inspection point. And then we go on and on. What if you're using, what if your activity is something that we don't want to allow you to do? You're logging into your IaaS, and should you be powering off production systems in your IaaS systems? No.
Yeah.
So I need to take behavior and activity into consideration. So it starts to all of a sudden be spread across what we call a zero trust engine. This idea that I don't just take one inspection point and consider it done. I need to look at your device trust. I got to look at your location, your application, your activity, your behavior, what type of data. All of that comes together to allow you to make the right decisions at the right time for the right reasons. And so all of that is taken into account when we start talking about adaptable trust. I'm going to start to adapt your actions that you're allowed to do based on all of those vectors of inspection.
What type of integration does that have to have with all these different things?
Ooh, good question.
Like when you start talking about the data side of things, most people couldn't even tell you where their data is. Never mind that application has sensitive data or highly classified data. Like, how do you get to that point? Like, location's fairly easy. I mean, maybe you can detect somebody's going through a VPN to fool their location. But when you start talking about that last level of, oh, you're trying to access something that has sensitive data, like, don't most people struggle with being able to classify that and find that? Like, how do you integrate with, I know there's tools out there that do that. Is that how that works? Do you integrate with those?
Yeah, so it's all gets based off part of an ecosystem, right? The ecosystem, it works almost kind of like the central nervous system of all of it feeds into a brain. And that brain is what's taking in all that insight and trying to make the right decisions on whether I should give you access or not, or what type of access I should give you or not. The data part is the hardest part. Without a doubt, that's where most companies struggle. To your point, one, we don't even know where our data lives. And if we do know where the data lives, how do I properly classify it as highly sensitive, right? Non-sensitive, external facing. That's the biggest challenge. What have most companies done? They've left it to the user that's creating the data, and you get like this pop-up when you go to save it. Is this highly sensitive or not? Most customers are like, nah. They do one of these like, I don't think so.
Big surprise.
Misclassify.
Surprise.
Yeah. And so therein lies, and I'm going to use this word again, Raf, the AI that can start to come in and create some intelligence behind oversight of the user's label or classification of data so that I can start to inspect and look into the data.
I both love that and hate it at the same time, Gerry.
I agree, man. It's this idea that, listen, when data's at rest, should I care how it's classified? Potentially, right? But the more risk, the greater risk is when that data is in motion. It's when I get that data and I start to move it somewhere. Now I want to know exactly what's in that data. So I should be able to apply the right security control on whether I'm going to let you move it or not. And so when that data is in motion, I want to look into it and say, hey, is there PCI data in here? Although it was tagged as, non-sensitive data, I should be able to look into the data and understand patterns. And that's where AI starts to come into effect. Is let me look at patterns. Let me look at categorizations. Let me look at capabilities of, is this actually a screenshot of, source code that's in here that I should probably not allow to go outbound. And it's the intelligence that AI and machine learning can really do effectively that is allowing a much more in-depth capability around protecting data that we just haven't had in the past.
Hold on. You promised me that, or maybe at least you said it. I don't know if you promised it, but you said it. Like, you want to avoid the speed versus security trade-off.
Yeah.
If we're going to be classifying things on the fly, do you still get that speed?
You get that speed if you can scale. So what was the challenge we had in the past as to why implementing more security impacted performance? It's because you had a fixed piece of hardware, right, that had a very limited CPU capability, and I couldn't scale it. It was fixed. My web proxy only could service so many packets and do so much SSL inspection before it just threw up. And the only way I can add more horsepower was to throw another box on top, and that just was ineffective. When we're talking about cloud, we can now have the agility and the scalability that cloud delivers. So as more and more data is coming my way, what can I do? I can spin up more workloads based off of containers, and I can expand kind of. There's a finite limit to cloud. It's not exponential, but I can scale it as the horsepower is needed, and then I can scale it down when it's not needed. And so therein lies the ability to deliver performance with security, is delivering a cloud security capability that can scale and give me the benefits and strengths that cloud provides, while delivering the security closest to where the user is, which is through a distributed nature of multiple clouds.
What's the cost though? What's the cost trade-off of that? Because I mean, you see articles, people talking about cloud is costing them a huge amount. Like if you've got a lot of data going back and forth and you're relying on AI that's scaling in the cloud as it's coming through, like what's that scale up look like? The cost trade-off benefit there of, yeah, it's going to cost you a ton more, or maybe it's just going to cost you a little more. But is this something that's going to still market out like SMBs and smaller organizations that say, hey, look, you know, I mean, I can handle $280 a month for my cloud stuff. I can't handle $10,000 a month when this thing starts scaling up and I have to handle
That's
that.
a great point.
Very good point, right? And that's why SMBs have always kind of been laggards in applying the latest and greatest technologies because they get priced out, without a doubt. But then the question lies is, well, what is the value of this data to you as a company? And what is the impact if you were to lose that data? What is the impact to your brand? What is the impact to your ability to be competitive in the marketplace? What is the impact to just your ability to do business? Think about what happened in Vegas just a few weeks ago, right? When they took down the MGM network systems due to compromise. Well, if they were losing $13 million a day, right? Imagine what they could have saved themselves if they would have, put forth $5 million worth of CapEx or OpEx to apply the right security controls to be able to protect and prevent something like that from happening. And so therein lies the decisions that CIOs, CEOs need to make is, what is the value of this data and what does it mean to us if it were to be compromised? And therefore, I need to apply the right amount of budget to ensure that I'm delivering the right capabilities to protect my data, my intellectual property, my brand. Now, the idea that, to an end user or to a company, they're not paying for the scale. They're not paying for that compute and that horsepower because they're not building it and delivering it themselves. They're subscribing to it as a service. And so it's up to companies like Netscope to be able to build, deliver, and scale and create efficient ways of delivering these capabilities without breaking the bank so we can be profitable, but still provide the best-in-class level of security and controls and deliver those capabilities that I'm talking about.
I had a quick question too. When you were talking about identifying the data on the fly, right? AI can identify it. It can see that it's a social security number. It can see that it's something else, right? And identify. Have we gotten better at that? Because I can tell you, every day I look at triage results and the Imperva incident ID is being flagged as a American Express card, right? Like, are we? And I remember years ago, we did a test someplace, and one of the biggest complaints, they were like, "Hey, look, they keep flagging this identification. They keep saying let's say it's a social security number, and they're like, it's because we created our IDs in that format." Well, one, you're kind of foolish for creating your IDs in that format, but is it better now to be able to detect and say, hey, yeah, it matches this, but also it matches this one, which overrides that, to say, no, it's not really.
Yeah, perfect example there, James, is the false positives has been a detriment to proper security operations command centers for forever, right? Then that's what generates that alert fatigue, is that we start chasing rabbit holes. We start going down the rabbit hole of looking for things that aren't really there. So what have we done to help improve that? Well, you start to have to teach. And instead of just creating a standard approach of saying, if it's a 9-digit character in a string of numbers, it must be a social security number. Now, that's not effective because user IDs and there's all kinds of things that might be 9 digits. However, what if I can look at things in the context of, in the full context of the document? Now, how do I start to make determinations on whether that is indeed a social security number versus a user ID? And so you can start to train, because it's machine learning, you can start to train the machine model that says, this is what our user IDs look like. Therefore, create a model that then is not applied to our PCI controls that enables our AI to make the right decisions on whether it's my user ID or it's a true social security number. And so you start to train the models, and all that becomes, it takes time, obviously. It's not an overnight thing where it's like I flip a switch and all of a sudden all my false positives go away. But the technology is getting smarter to where I can start to train it, just like I train an individual to look for the right patterns, so that we can be more effective at stopping and protecting against data leak.
All right. Well, before we run out of time, I want to give you one more. We'll give you 60 seconds or so to wrap it up. Look down into your crystal ball. Give me the where we're going to be in 3 years. What are we going to are we going to be there? Whatever there is, still on the journey, or someplace else?
I think where we'll be in 3 years is the idea that we're no longer looking at security as a completely separate entity in my organization from my network teams. SASE is kind of the future direction that we're headed in. SASE being SSE, Secure Services Edge, which are all the security controls that we've always known: secure web gateways, web proxies, DLP, cloud access security broker, VPNs, things like that. Integrating with the A, which is access, which is the network layer. So all of that's starting to converge, which is why we have SSE kind of merging itself into SASE, meaning I can't just do security and be done with it. I need to actually enable and deliver proper access. And so I see a true consolidation and efficiency being driven into the industry of saying we're no longer backhauling traffic to the data center, back to where our security controls are, because that's not where the ultimate destination of my packet is going. It's going back out to the internet. So therefore, this concept of building and delivering security at a data center is going to go away. That's where I see over the next several years. Then the concept of, well, then how do I apply the right security controls to my users that are now distributed everywhere? Well, I need to deliver it via security cloud. And so just like I subscribe to AWS, GCP, Azure for compute, I'm going to subscribe to Netscope for security. And all of that idea of maintaining and operationalizing infrastructure goes away. I no longer have to lifecycle manage. I no longer have to maintain all of these appliances. I literally just subscribe to it as a service, and every single one of my users now all of a sudden gets a high-speed on-ramp to the internet through a secure cloud. And so my security controls are being applied using all of those vectors that I mentioned across a zero trust engine: device, location, app, activity, behavior. And now I can start to implement adaptable policy. And that's when we start to truly get the best user experience. Is now I don't have to think about, oh, I got to turn on my VPN because I got to get connected to the office because I got to get access to my app. I just access it directly. And we can drive costs down. I no longer need high-speed private circuits like direct connect and express routes. I literally am just from wherever I'm at going directly to where I need to go, but I'm doing it in a secure way because I'm passing through a security cloud. And I think that's where the future's headed, is moving it into closest to the user as opposed to a physical stack of infrastructure in a data center.
Well, I like that promise. I feel like we're getting there, and I'm looking forward to a lighter security stack for the corporate IT security team. So, Gerry, thanks for joining us. This has been fun. I picked up a couple of new concepts. I like where this is going. Thanks for clarifying some things, and yeah, this has been good. Thanks for joining us.
Absolutely, appreciate it. Thank you both.
All right, James, I learned something. I think I had to do every episode.
Yeah, this was good.
All right, folks. Thanks for joining us live. Those of you that did, if you didn't, check out our LinkedIn Live options. I know we post some of these episodes to LinkedIn Live. They're definitely out on YouTube. Should you prefer the YouTube version, see our smiling faces and ever-changing colors of James's shirt. And
I need to get one that's got all the colors. That way I just wear that one.
There you go. You got to, that's what you got to do. So, all right. For the Down to Security Rabbit Hole podcast, this is Raph, and that's James. And we are out of here. Cue the music. We'll see you guys another time, another place on another Down the Security Rabbit Hole podcast.